Welcome to my final project walkthrough video. First, I'm going to demonstrate to you that my code compiles. Okay, let's save that. Run make. No errors, which is what we want. Let's run mish. Okay, I'm going to walk you through an example of running a process in the background. What I should expect to see here is a job ID along with the process ID. That's exactly what we see. If I run PS, as you can see, we have a sleep command and the process ID associated with that command. Let's say if I want to kill this process, what I can do is type in the process ID and send the signals. Okay. The next time that I hit a command or enter, I would see a done message display. And let's talk about how my code handles or manage these process. So I have these data structures, job manager and background manager here. These two differ slightly. So background manager would keep track of all the background commands, whereas job manager would break down, let's say, a pipe command in the background into individual commands, right? So for example, if I have a pipe command sleep 50, sleep 60, like this entire command here would be treated as one item for background manager, but for job manager, it will be treated as two separate items, right? The way I choose to implement this is so that I can, uh, job manager purpose is to implement PS, right? And then background manager purpose is to implement these single messages for one command at a time, right? And let's say if I want to kill the first sleep command 1283658. Okay, that is killed. And the way we know it is if I hit enter, um, kill 1283659. Now both commands are killed so that the pipe command would be complete. That's why we see the done message here, right? I will show you the code that would emit the done message. It's in IO helpers. So I have this helper called check background process status. What it would do is it would loop through the background manager. I should probably show you what background manager stores. The background manager store background process nodes. What that data structure looks like is here. It has the job ID, it has a command name, it has the process ID, and a variable as the status is done status, right? So basically, it will loop through. Let's go back here. The for loop will loop through background manager and check to see each process is done status. If it's not done yet, then remember I have a reference to the process ID, right? So I can use wait PID with no hang to check the status of that process up until the point of this function, right? If it's done, I will update the status in the background manager and I would display that done message, okay? And you would see in Mish, I sprinkle this check background process status throughout my Mish. So after I get the input from the user, I call it once, and then after Mish executes the command at the end here, I also call it again, just to make sure the process status is the most up to date. But typically, the done message would be displayed after the user inputs something, right, from the SCD in, right? Now let's talk about how I handle signals. So in Mish.c, I have the boilerplate code to set up handling signals, specifically for sigint. So I handle it by just writing a new line to the terminal, nothing special. And this is the only place I have handling signals because for sending signals to child process, I use the default behaviors. There's no need to modify the default actions based on the project requirements. So that's why the mish.c is the only place I have a signal handling for sigint. Right. Some people also implement or they implement handling signals using sigchild instead of using wait. I decided to use wait just because wait was introduced in lecture. I'm more comfortable with it because I've done labs using the wait function. So that's why I decided to go with wait instead of sigchild. Right. Next, let's move on to how I handle receipt message of the client. So I have server side and client side. Both have the boilerplate code to set up the connections. So as you can see here, this is the server um, creating a socket, binding, and then listening for incoming connections, and setting up the signal handler here for the server because I want to run the server in the background, right? And the way I will terminate that server in the background is by sending the signals. It's also because this is how the lab 10, the networking lab was implemented. So I don't want to deviate much from it to simplify the design choice, right? And similarly for clients, I also have the boilerplate code for setting up the signals and setting up the connection, creating a socket, connect to that socket, right? Okay, so both client and server have FD sets to for select. For clients, the FD set contains SCD in and the server socket. This socket file descriptor would be responsible for transmitting message from the server to the client side. Now, if the client detects that, okay, there's some input from SCD in, what it would do is it would send that data to the server. And how it does it is by reading 254 bytes at a time. Why 254? Because I want the maximum number of bytes, including CLF and the node terminator, to be 256. So the maximum number of bytes clients can send to server at one time is 256, right? And after that, the server side, the server side also have FD sets for select, and it has a linked list of all the client sockets, right? It will loop through this linked list to check to see if the file descriptor socket of a client is ready or not. If it is, then we would read from that client and we would get the message from the client, right? The idea here is I have a write buff to format the message that will be sent from the server to the client. The format is a bit different compared to the message the client sends to the server because the server has to append the or has to format the client ID at the beginning of the message. Right? So the client ID and then the actual content of the message from the client. Right. And then I loop through all the client sockets and then write the actual message to the client. As for the client, at this point, the server socket FD should be ready, right? Because the server just sent a message to the client. So what the client would do is that it would read from the socket and it would get that message using these helpers, get message that I developed during lab 10, and then I would display it to SCD out. That's the idea. Let's talk about how I handle very long messages from the client. Let's say the client sends a message that's 200 and more than 256 words long, right? Because the maximum number of bytes the client sends one time to the server is only 256. The way I handle over long message is cutting up that long messages into bytes or into chunks, 256 bytes each, right? So that long messages will be treated as multiple messages to be sent to the server. And the server would treat each chunk of that big message as an individual message, properly formatted, and send it back to the client. The pros of this approach is that it doesn't put a hard limit on the number of bytes or how long a client can send a message because the entire content of the message will be reflected or will be sent to other clients and the server. Well, the cons to my approach is that there could be a word that's right at the border of that 256 bytes threshold, right? Let's say data is the word on that threshold. It could be the case where the letter D is the 254 byte character. And so there will be two messages. The first message would end with D, and the second message would start with ATA, which is not very ideal from the user experience, but in terms of functionality, it works. And so that concludes my final project walkthrough video. Thank you for listening.